everyone. In lecture 6, I want to look at the very interesting topic of embodied perception in sport. And this is going to foreshadow something we're going to get into in the module number 4, when we talk about a very different way of looking at kind of sports and training and skill acquisition and perception called the ecological approach. And this one is, maybe our brain is not doing what we think it is, doing all this processing and being like a computer. So this is going to touch on this idea a little bit today. This is also an area you'll see that I've worked in a fair amount, so you're going to see some of my research. So the traditional view of perception is the idea that what our brain is trying to do, what our perceptual system is trying to do, is faithfully represent what's out there, right? So the perceived size of an object should depend on its physical size, right? So if I have a ball, a football, and nothing else changes, I should always see it as the same size, right? We want our perceptual system to be a reliable and consistent measurement system, like a device like this, right? Our eyes like the device, a rangefinder that measures distance. But this doesn't always seem to jibe with what athletes say when they describe what they experience. Athletes talk about seeing a baseball as big as a grapefruit or small as an aspirin. They talk about throwing a ball in the ocean when you're a basketball player, things slowing down, right? So there's these kind of references that our perception might be changing based on how we're acting, right? And that's kind of the essential idea of embodied perception. Body perception theory really is modernly associated with Dennis Profit, who's done a lot of work in this area, but it really extends from James Gibson, who we're going to hear a lot about near the end of the course when we talk about the ecological approach. So the idea is that we're not just, perceptual system is not just a passive measurement tool like a rangefinder in that image. Its job is not just to just measure what's out there, right? What we are is we're perceiving the world as embodied based on having a body, being a person that's going to act on the world. So we're perceiving the world in terms of not only what's out there, but also our capability of acting on it. So perceived size is not just based on the physical size, but also our ability to act on that object, our skill level, how fatigued we are, so on. So that's the basic idea of embodied perception. So this fits with the athlete's descriptions we showed a second ago, right? When you're performing very well, you have great capability, an object should look bigger, right? Like a grapefruit. When I'm struggling and not very good at something, objects should look smaller, like an aspirin, right? So that's the basic idea of embodied perception. Let's look at some examples. One of the most famous examples is work by Dennis Profit, who what he had people do is stand at the bottom of a hill and try to judge the steepness of it in a variety of different ways, using this device where you adjusted the angle verbally and a bunch of different ways. And he measured in two basic conditions: when you're just standing like this, and the person might say 20 degrees or set 20 degrees. His big innovation was to do the same thing, but what happens if you give the person a heavy backpack full of books, right? In the traditional view, this shouldn't change anything, right? The hill hasn't changed, the slope hasn't changed. You shouldn't perceive it any differently. In embodied perception now, we've decreased your capability to act, right? We're going to make it harder for you to get up that hill because you have weight to carry. That should be manifested in changing your perception, making the hill look steeper. And that's exactly what he found. When he added the backpack, people judged the slope as being slightly steeper. This kind of this embodied perception effect. Action capabilities go down, perceived slope goes up because it's more difficult to climb. Profit argued that this serves as kind of a selection mechanism to preserve resources and make it more efficient. And since then, a bunch of people have done things like, for example, why do people choose stairs versus escalator in a mall? And they find that people that tend to choose escalators more often tend to have less capacity, right? They're heavier, they have shorter legs, they're older, they're carrying more, and so on. So choosing escalator that's because maybe the stairs look steeper because you're less capacity serves to conserve your resources. Okay. In terms of sport, one of the most interesting things that's been studied, this kind of extending from those quotes I showed you at the start, is the changes in perceived ball size. And this really started with Jessie Witt, who started as a grad student as Dennis Profit and got on to do tons of really interesting work on her own. And what she did was she went to a baseball field and asked athletes, she printed out this thing and asked, what? It was life size, right? She asked them, which of these circles represents the size of a baseball, right? And they had to match it. And what she did cleverly was she looked at, after they did that, she looked at how well they performed in the tournament they were playing in. Okay. The athlete that just performed well in the tournament would say it's 6, while the athletes that performed poorly would say it was 4, right? So again, a capability, your performance level goes up, perceived size goes up, it goes down, perceived size goes down. Okay. Embodied perception. Okay. So questions that I kind of started to study when I got in there, this was how precise is a body perception? What function does it serve? We talked about this idea that you use it to select action, what causes it, and so on. Okay, so what I did in this study was this is a study I did, and I studied baseball batting for a long time, and I have a baseball batting virtual environment, a VR that I studied. So what I did in this experiment was I gave athletes a different goal. Okay, so the hitters on some trials they just had to hit the ball anywhere on the field. On another set of trials they had to do what's called pull hitting. That's where you had to hit the ball to the same side of the field that you're standing on the plate. Another set of trials they had to do opposite field hitting, right? Which is hit the ball to the opposite side. The reason I did this is because I wanted to create a situation where certain pitches would be more effective depending on the goal, right? When you're trying to hit a pull hitting, pitches that are closer to your body are easier to achieve that, right? Because you can get around on them. When you want to put the ball to the opposite field, inside pitches are not good for that. You want pitches that are away from your body, right? So I created this situation. So pull hitting, you want pitches on the inside, you're attacking the ball. Opposite field hitting, you need to wait, and you want pitches on the outside, further from your body. So I created this kind of different environment. And what I kind of hypothesized was that when I tell you to do pull hitting, maybe pitches on the inside, the ball's going to look bigger than ones on the outside. And when I switch the task, you get the opposite, right? So I did this in my virtual environment, where it looks kind of like this, a projection system, person holding a bat with a motion tracker. So I had people doing the hitting task. Then after each swing, I'd ask them to make a judgment about the ball size. Okay. So do the thing, judge. They also had to do about the speed and things like that. Okay. Well, I mixed up the different variables. And what I found was this. Okay. When I gave you the unconstrained task of hitting it anywhere, what's on here is the direction. Was it closer to your body, down the middle of the plate, or further from your body? The pitch. This is the percentage of times you said it was larger than the regular ball, right? For when you're unconstrained, it doesn't matter where that's this flat line. It didn't matter where the ball was going. You pretty much made the same side judgment. When it was pull hitting, balls that were closer to you, you perceived as larger, right? Just like I predicted, and vice versa. So it seems like it's not only capability in terms of broadly, like what skill level or age or whatever. It's also based on your task, what you're trying to achieve. Okay, so I found this basic effect. There was a relationship between this and actual hitting performance as well. Can't go through that. So it depends on what you're required to do. Okay. And they would roll from. So the idea is this is consistent with this action selection idea, right? If I perceive inside pitches as bigger when I'm pull hitting, I'm more likely to swing at them because it look more hittable, right? Which is good. I want to do that because it's easier to achieve my goal there. That was a basic idea. Okay. Um, to test this more rigorously, what I did was in the simulator, right? I can artificially change things, right? So I can artificially change the size of the ball in the simulator, unlike in the real environment. Okay. And what I did with this was to create situations where all the inside pitches were larger. So when the ball was inside, it was actually bigger on the screen outside. So these aren't just perceptual errors. And what I found was that people in general, when you make the ball artificially larger, they're more likely to swing. Okay. So what they're perceiving, I think, is not the actual size. They're perceiving how hittable the object is, right? So the more I increase the diameter of the ball in the simulation, the more likely you were to swing. It looked more hittable to you. Okay. Um, the number of when the outside pitches were larger artificially, you hit more to the opposite field, which was you expect, right? That's what I found in the other thing. Okay. So we can manipulate what the people are doing by making pitches look more hittable by artificially changing the size. Okay. I just put this in. I also found this effect in aviation, right? When pilots are more skilled, the runway looks different sizes, right? I'm not going to go through all this. When we have novelist pilots, the more well they control the plane, the larger the runway looked, right? So this is showing how hard they landed and the judge size, right? So you get this kind of effect in the aviation as well. I'm going to click through these ones. So kind of the same effect, same embodied effects. But last one I want to talk to you about in terms of sports is in golf putting, because I wanted to see what causes this specifically. Why do inside pitches look bigger when you're pull hitting? What's the mechanism involved? And so this is a paper that's been published several years ago now. These are old slides. But what I had people do in the study was what particularly were interested in, is this effect caused by attention, right? We're going to get to the course. We're going to talk later in the course about the role of attention in sports specifically. But attention, right, is when you focus on specific things in your environment, right? You can focus on me. You're paying attention to me, hopefully, and blocking out things going on in the background, right? The idea is that when you attend to something, maybe it gets enhanced, right? You hear my voice more clearly, you understand what I'm saying more clearly. So what we want to test in this is maybe the reason the ball looks bigger is because your attention is drawn to it. Okay. So what we had people do is putting in a lab. After each putt, they had to draw the size of the hole on the screen. What we did was to present sounds to different parts of their swing to see where their attention was, right? Were they focusing on the club? Were they focusing on the hole or whatever? Okay. To do this, what we did was we had speakers by the hole and we played a sound. In one set of conditions, you were asked, was the sound coming from the left or the right? So you're basically, to do that, you would have to be paying attention to the hole. In the other task, we asked you to judge, what did the sound occur in your backswing or your downswing? To do that, you'd have to be paying attention to your club. So how well you did on each of these is going to tell us whether you're paying attention to your club or to the hole. Okay. And so what we did was we expected that when we put people under pressure, and we did this by social pressure and giving them money. And again, we're going to talk about performing under pressure later in the course in more detail. What we did was we found that this caused people to focus their attention on themselves, on the club, and actually influence the way they controlled the putter's putting stroke. Okay. So what we did was we had people under pressure. 11 of the people in our study that we measured got worse under pressure. They choked, the common phenomenon of choking. Whereas clutch people stayed the same under pressure. They had the same level of performance. How does this relate to perceived size and attention? So the people that were clutch underperformance, so this was before we had the pressure, we add the money and the being observed by others, a crowd, then we take it away. What you could see is the clutch people, they perceived the whole, they putted the same. This is the error in the putting performance. They stayed the same. The choke people got worse, right? That's why they choked under pressure. They had bigger errors in putting. Now look at perceived hole size. The choking people, the red is the actual hole size. The people that were clutch didn't really change at all significantly, whereas the choking people, this hole was perceived as being smaller, right? So it went from this to that, right, under pressure. It looked like the hole was getting smaller because the pressure was getting to them. They also, if we look at attention, right, this was the percentage of correct judgments about which speaker, right? So to do that, you need to pay attention to the whole. What you can see is the clutch people were about 80% correct always. The choking people got way worse at that and actually were just at chance level of guessing when under pressure. So suggesting they stopped paying attention to the whole and started getting better at judging what their club was doing. They turned their attention inwards. Okay, so this seems like this change in perceived hole size and probably the ball size we saw in the baseball study are due at least partially to your attention shifting to different places. And attention can shift for lots of different reasons, instructions, pressure, and so on. Okay. So we get this inward shift of attention with perception, which causes you to not attend to the whole, which makes it look smaller. That's the idea there. Okay. Um, So it's possible, the idea that we could perhaps improve people's performance by training them, with this, and we'll talk about this later in the course. Okay. So perceived size of objects is not purely based on their physical size, what's out there in the world. We don't perceive the world accurately, is another way to say it. We perceive the world in terms of our ability to act on it, our capabilities. This is the fundamental idea of embodied perception. Okay. It's talking, maybe there's, even though we tend to like to ignore what athletes say as kind of being hyperbole and nonsense, maybe it's meaningful after all, right? This player saying tonight the hoop looked 20 feet wide. Maybe that's what they actually perceived because their capability was so high. So that's a topic of embodied perception. As I said, we'll get to that later in the course. You can learn much more. There's some really cool examples also in the book chapter that you're assigned for this that I go into detail, expanding on the stairs versus escalator idea. Lots of fun examples there. So I hope you enjoy that.